Unit 11, Section 3, Angles and Angle Measures. Alright, the first part, radians and degrees. So we want to convert each measure to radians or degrees, depending on what it says. Before we do that, let me show you or give you notes on how. So if I want to find, let's say I have degrees, so I want radians. And in case you don't know, which is okay, a radian is a unit of angle measure, and it's based on the arc length of the angle. That's all that means. Okay, and then radians are always in terms of pi. So if you're talking about radians, you should always see pi somewhere in there. Okay, but if I want a radian, that would be equal to my degrees, so whatever I have. So if I have 50 degrees, I would put that here. It's my degrees times pi divided by 180. Okay? And then you can reduce the degrees in 180 if you can, and then so you should end up with pi in the answer. Okay, if I want degrees, let's say I have radians. I'm just going to flip that fraction. So I'm going to go ahead and do my radians. So let's say I give you pi over 2 radians. It'd be whatever radians you have, you put here, times 180 divided by pi. And because radians always include pi, when we divide, then the pi's kind of, in a sense, reduced to 1, cancel out. You don't have them anymore, which is why the degrees don't include pi. Anyways, those are the two formulas you need for these questions. Okay. And convert. So convert the following measure to radians. So I have degrees, so if I go to my formula, degrees equals, I want radians. So radians equal degrees, so 270, right? So if you want, that'd be your parentheses, times pi over 180. Okay, I'm going to go ahead and just rewrite this as 270 pi divided by 180. Okay, that's the one fraction I would have. And I can reduce that. So first off, both of these zeros can go away, right? Because it's dividing by 10. So I have 27 and 18. So if you want to, we can rewrite that first. So make the numbers as small as you can. 9 goes into both of those, right? So if we divide by 9, we would get 3 and 2. So then my final answer would be 3 pi over 2. And that'd be it. Alright, number 2. Convert the following measure to degrees. So this is the radians, 1/6 pi. And we're going to use the formula that we have down there. So degrees equals, well, let's go. We have radians times 180 over pi. Okay, so here's my radians, right? Times 180 over pi. Okay, again, I'm going to rewrite this as just one fraction and then reduce. So I have 1 pi, the pi is not part of the fraction in here, but because it's not a fraction, it actually is included on the top. So 1 pi times 180 is just 180 pi over the bottom 2 is 6 pi. Okay, right away, this is why we divide by pi to convert to degrees. The pi goes away. Okay, now I'm just left with this number, 180 divided by 6. Now, 6 goes into 180. We can divide that, right? 6 goes into 18 3 times. And then the 0 we just tack on there. And make sure you put the little degrees symbol. And we're done. So that's how you convert between radians and degrees. There we go. So again, be sure to practice that. It seems very simple, but without doing it a few times, when you get to the quiz or a test, you may not remember right away. So if you just do it a few times, it'll be really easy when you do it again later. Next part, coterminal angles. We want to write one positive and one negative coterminal angle to the given angle. Okay, notice one is in degrees, one is in radians. Alright, so a coterminal angle is just an angle in the standard position with, this is the technical version, with the same terminal side as the given angle. Pretty much what that means is, let me draw a picture, maybe that'll help. So I have a coordinate grid, right? So on a coordinate grid, I can graph an angle. Let's say my angle is right here. So here's my angle, right? Let's say that's 45 degrees. A coterminal angle is if I take that angle and I'm going to go all the way around 360 degrees and I'm going to have a different measure but in the exact same position. I can also take that angle from the 45 and I can go backwards 360 degrees and have another angle, different measure, in the exact same position. That's all coterminal angle means. Co meaning together, and then terminal mean, just the terminal means it's the distance from this angle to the x-axis. Okay. Now, all we're doing here is we're going forward a full circle and we're going backward a full circle. That's how you get one positive and one negative. So you're going to add a circle and subtract a circle. Now, to do that, if we have degrees, to find coterminal angles, you simply add and subtract a full circle, which is 360 degrees. Okay. Now, depending on where you start, you may have to add twice or subtract twice to get to a negative or positive. Just depends on where you are. But essentially, you're just going to add and subtract 360 degrees until you get to a different measure, one that's positive, one that's negative. Okay, for radians, we're still going to add and subtract a full circle. But for radians, you're going to add and subtract 2 pi, because 2 pi is a full circle in radians. Okay. So again, sometimes you may have to add or subtract more than once to get a positive and negative, depending on where you start. The one thing about the radians that you don't have to worry about with degrees is with radians, you have to make sure you have common denominators. Because most, I won't say all because that's not true, most radians are in fraction form of some kind. That's the only way you have an exact measure. So for radians, you may have to convert 2 pi to something, some fraction pi, right? Depending on your fraction. And we'll do that in the example. So pretty much you're just adding, subtracting either 360 degrees or 2 pi. Okay. Number 3 is 178 degrees. I want to write one positive and one negative coterminal angle. So because we have degrees, we're going to add, subtract 360 degrees. So I'm going to do 178 plus 360 and 178 minus 360. Those two answers, if they are positive and negative, would be my answers. So if I add 178 and 360, you get 538 degrees. So that is a positive, that's good. 178 minus 360, you get negative 182. So I have one positive, one negative. That would be my answer, or my answers for this question. So if I had added or subtracted and I didn't have one of each, I would have to do at least one more to get there. So add and subtract 360 and you have your answers. Number 4 is 4/3 pi. So on this one, we want to add and subtract. So add, subtract 2 pi. Okay, but we have 4 over 3 pi, and this is 2 over 1 pi. So we want to convert this to a denominator of 3. So all I do is multiply by the denominator on the top and bottom. So since my denominator, my bottom is 3, I multiply by 3 on the top. If it was 4, you would do 4 over 4. 5 is 5 over 5, and so on. So now I'm going to add and subtract. 2 times 3 is 6 pi over 3. Now I can, because same denominator, so I'm good to go. Alright, so I have 4 pi over 3 plus 6 pi over 3. And then I have 4 pi over 3 minus 6 pi over 3. So I do 4 plus 6, I get 10 pi over 3. I can't reduce that, and it's positive, so I'm good there. On the next one, 4 pi minus 6 pi is negative 2 pi over 3. I can't reduce that, and it's negative, so I have one positive, one negative. That is my answer. So degrees, add, subtract 360. Radians, add and subtract pi, or 2 pi, sorry. Also, I don't know if maybe you realize this, if 2 pi is a full circle, 1 pi is half a circle, or 180 degrees. Alright, last part is we have reference angles. Write the reference angle for the given angle measure. Okay. So the reference angle, again, maybe a picture will help, and I'll get to that picture down there. Reference angle is, say my angle is right here. Let's say it's 60 degrees. The reference angle is this angle, which in this case would also be 60 degrees. But if my angle is over here, let's say this is 120 degrees, my reference angle is this acute angle. So reference angles are always acute, and they're always positive. So it's the distance from there to the x-axis again, like the terminal side. And this is 180. That would also be 60 degrees. So your reference angle is just the acute positive angle from wherever you are located to the closest x-axis measure. So before we do this right here, let's go down here and fill this out. Okay, first thing. So this is what coordinate plane looks like. You have x-axis, y-axis, you know that. First thing I would label is quadrants. So we have quadrant 1 is right here. Quadrant 2 right there, and then 3 is down here. And then of course 4 is the last one. Okay. The reason they go in that order and not clockwise is because that's the in order going positive as far as rotating in a circle. Anyways, so quadrant 1 is top right, and it goes counterclockwise to 4. In quadrant 1, if you have any angle in quadrant 1, it'll be anywhere from 0 degrees to 90 degrees. So anything in between there is quadrant 1. Quadrant 2 starts anywhere between 90 degrees and 180 degrees. Quadrant 3, 180 degrees all the way to 270 degrees, 270. And quadrant 4 starts at 270 degrees up to 360 degrees. Okay? Now that's degrees. We got to do radians. So in quadrant 1, you'd have 0 pi up to 1/2 pi. Quadrant 2 is 1/2 pi all the way up to pi. Quadrant 3 is pi all the way up to 3/2 pi. Quadrant 4 is 3/2 pi all the way up to 2 pi. Okay? Now we can also label, so I'm giving you the range for each quadrant, but let me label each, I guess, axis point or line, whatever you want to call it. So far right over here is going to be 0 degrees and also 360 degrees. The top, so that's the 0. Quadrant 1 is from 0 to 90, so this top one going up is 90 degrees. Then we go to the next one, maybe you've already guessed, is 180 degrees. And the bottom one is 270 degrees. Now we do radians. This first one is going to be 0 pi or 2 pi. And the top one up here is going to be 1/2 pi. The left one is pi. And the bottom one is 3/2 pi. Okay. That way, no matter what angle you are given for this type of question, for reference angles, you should be able to figure out which quadrant it is in. And again, reference angle is how far from that given angle to the x-axis right here. So no matter where I am, I should be going to 0 or 360 degrees, or 180 degrees. Or if it's radians, I should only be going to 0 pi or 2 pi or pi. Okay, so I'm not going to the y-axis at all, I'm going to the x-axis. So you got to figure out what quadrant you're in, and then you go to either the left side, pi 180, or the right side, 0 360 or 0 pi 2 pi. Now, if that sounded confusing, I apologize. Hopefully the examples will help. Okay, number 5 is a 178 degrees. Okay, well, for me, I feel like drawing a picture helps, because if you can see it, it might be easier. So 178 degrees, let's go back down here. Well, I have to scroll down, y'all have it on the paper. 170 is in between which range? Well, it's in between 90 and 180, right? So it's in quadrant 2. So if I were to draw this, 178 degrees, I know it's in between 90 and in between 90 and 180, because of 178. So it would be, probably shorter than that, but just to be able to draw it. Let's say it's over here, it's in quadrant 2, and this is 178 degrees. My reference angle is going to be how far from 178 degrees to 180 degrees. Because that's an acute angle. I could not, don't draw this, I could not go this way to 0, because if you notice, that would be an obtuse angle. I don't want that. Reference angles are always acute. So since I'm going from 180 or 178 to 180, I will subtract. You're finding the difference. So 180 minus 178, 2 degrees. That's it. So you simply find which, what direction you're going from your given angle, and subtract to find the reference angle. So your reference angle should always be less than 90 degrees. Okay? Or less than 1/2 pi if you're doing radians. Speaking of radians, we have 6 is 4/3 pi, 4/3 pi. Okay, you might be thinking, well, here, let's draw our picture, right? You might be thinking, okay, I'm not sure where that falls on this picture, down here that we did. Where'd it go? Here it is. So 4/3 pi. Okay, I don't know what quadrant that would be in. Okay, well, if you notice, the only fractions I have for these are 2, right? Well, first off, let's do this. 4/3 pi. since 4 on top is bigger than 3, we know it's greater than 1, right? So it's not going to be in quadrant 1 or 2, because 4/3 is greater than 1. So it has to be between 1 pi and 2 pi. We just got to see where it lies in regards to 3 over 2 pi. So we can do that real quick. So if I want to know if this is greater than, I'm sure maybe you recognize, you have this little circle, you put the greater than, less than, equal to 3 over 2 pi. Okay, my denominators are not equal, therefore I cannot do this easily, but I can convert these to the same denominator. Then I can see where it would, if it'd be greater than 3/2 or less than. So let's go ahead and do that. So common denominator would be 6, right? So I multiply this one by 2, this one by 3, and I would get 8 over 6 pi, right? And then 9 over 6 pi. Okay, now we can see 9 is greater, which means 8 over 6, or in this case 4/3. So we have pi right here. We have 3 over 2 pi right here. If it is less than 3 over 2 pi and greater than pi, I'm somewhere in quadrant 3. And again, the exact position isn't really relevant. It's just the value of the distance. That's what we're really finding. So you can draw your picture. As long as you're in quadrant 3, I think that helps to see. So here's 4/3 pi, somewhere in quadrant 3. And I want to find how far it is from that angle to pi. Okay? So in this case, since 4/3 is greater, I'm going to subtract. I have 4/3 pi minus, whoa, not that, pi. Okay? So I'm subtracting. I'm finding the distance. Now, I can't do 4/3 minus 1, right? Because this is actually 1 over 1. But if I make a common denominator, which I need, then I can subtract. I can multiply this one by 3, and then I would have the same denominator, and I could subtract them. So if I do that, I would end up with 4/3 pi minus 3/3 pi equals. Okay, now I can subtract, right? Remember, when you subtract or add fractions, you only change the top number, never the bottom. So don't subtract the bottom number, because then you would get 0. Can't do that. Okay, can't divide by 0. So 4 minus 3 on top would be 1. The bottom doesn't change, and then keep the pi. I'm not doing pi minus pi, right? So the pi should always be there. The denominator, the bottom, should always stay. It's only the top that I gotta add or subtract. Okay, so 4 minus 3 is 1. Can't reduce that any further, so that is my reference angle. It is positive. It is less than 1/2. And that's my answer. And that's it for the notes.